Oh yeah, one thing I left off. So I said that this thing, there's a top and a bottom. I kept calling this one up here the top and the smaller one the bottom. So that's important. So just as we all know how liquids work, because of gravity, they puddled to the bottom, right? So if you were to flip this thing upside down and have your freon condense and exit the top, it would just back up. The liquids would try to drain down into the gas section. You'd have a mess. So it's important, it's required when you install a condenser that the fluid that enters, the freon that enters as a gas, has to enter the top of the exchanger, and then as it condenses, as it goes across, it turns into a liquid, but a liquid will just drain back. So you can tell basically the gases will be flowing, which keeps the flow rate going, but gravity's working in your favor to keep that liquid moving to the bottom, and then you just have a continuous supply of liquid going to the either expansion valve or orifice tube. Since this is a 99 Miata, I'm sure it's got an expansion valve. But anyway, that's a little important thing. So when we install this, you'll see that big one will stay at the top for sure. And anyway, I'm gonna go check out that stock condenser, see what it looks like. Alright, so here's the factory condenser. And I'm having to re-record this because upon further inspection, this is a 5-pass. I thought it was a 3, but this is actually a 5, so looks like we might have got a downgrade going from a 5 to a 4, but I thought this was a 3. It's actually a 5. So anyway, here you can see they got freon coming in. We got a little divider wall right there. And then there's another divider wall towards the bottom here. And there's 2 on the other side as well. So basically freon kind of goes here across the top, scoots down, shoots across, comes down again to that wall, back across, down again, all the way across here. And then the very last one shoots across these tubes. And when it gets here, you can see there's a divider wall. So that's actually a 5-pass, surprisingly. But you can tell this one is a little bit different dimensions. So we're going to check that and make sure that we're not screwing up before we spend time installing this new condenser over there. But anyway, that's how the factory one works. Alright, so we did some quick math. So the heat exchanger, I measured the tube dimensions, so I didn't count. So I wanted to do like a length and a width, and I didn't count the little fins on the very last one. I started with the first tube all the way to there. And if we do it that way, our stock heat exchanger is 239 square inches. The new one's 246. So they're about the same size. This one's just a tiny speck bigger. And then the stock one is a 5-pass, and this is a 4-pass. Now, admittedly, I wanted the inlet and outlet on the same side for this, and you can't have a even number, or you can't have like a 5-pass and they both come out on the same side. So maybe that's why they did a 4 and not a 5 or a 6 or something. Anyway, kind of funny. How's that for, you buy a brand new part and put it on a 20-year-old car and it's a downgrade in performance. Kind of sucky. But yeah, that's one of the funny things about aftermarket parts. Sometimes they don't have the level of engineering you would think they'd have. Because I would assume, and there could be something else going on that I don't know about, but I would assume that a 20-something-year-old part would be designed better than the old one. So, who knows? Maybe there is. I mean, these end tanks are bigger. I don't know if there's really any benefit to that, but these are physically larger than the end tanks on the factory one. What else? I guess like the tube and fin geometry could be different. I know in the car world, that was a new thing that happened, and radiators, they basically improved the fin density. So, maybe I'll look at that. Wouldn't surprise me. Now I'm curious to see if the fin density is any different. But, yeah. That's the numbers we found for the comparison. Alright, so we just kind of eyeballed the fin density. I didn't pull out a caliper and try to measure it. But it does look like the OEM one has a slightly more dense fin density. So, yeah, it's likely the case that this is a 4-pass instead of a 5, and it has a lower fin density. So, that's kind of not what I was looking for. That's probably a downgrade. I don't know how big a difference it makes, but this probably is a lesser heat exchanger. Now, granted, it's aftermarket, so it's easy to install. It's got common fittings that regular hoses fit. It definitely has some, and it's cheap, so it's got some stuff going for it. But performance-wise, and I guess, so cooling-wise, this is probably worse. The fin density is not going to let, it's going to let air flow through it more freely, but it's not going to cool as well. Well, in theory, I guess. Maybe they did some engineering and the air flows better, and since there's more of it, it helps. I don't know. But I think generally the case is that having the higher fin density actually helps. Anyway, it's different. Hopefully this isn't a downgrade because it was intended to be an upgrade. But yeah, that's where we're at on this condenser. Now we're gonna have to pull some actual dimensions and see if this is gonna fit. So here's our first dimension. We just kind of got this set about where that mounting bracket is. Now if we come over here, that's what? Just barely over 27 inches. But over here we got fittings poking out. So 27. Go check the car, see what we're working with. Do you see what I see? Barely over 27. So, looks like we're probably in for a packaging nightmare. Alright, so we're looking at this, and there's a big reason why we ran this condenser that I haven't mentioned, and I kind of forgot about, but I'm starting to remember now. So, the width problem of being basically as wide as the car, that's, I don't know how we'll figure it out, but we basically looks like we have between 0 and 1/4 inch of clearance, so that's awesome. But here's the actual reason we're doing this, now that I remember. So if we use a stock condenser, it has a hard line that comes out, it's brazed or welded or whatever, right to the tank. It comes out very short, and then you have the dryer. And that is the problem. This dryer is big, it's clunky, and it's sitting right on the face of this heat exchanger, which prevents me from putting another heat exchanger anywhere remotely close to this. And that is a huge issue. I didn't pull out a tape measure, but I mean, this thing is easily 2 inches or more in diameter, probably bigger. So that is the actual main reason we did this. And you can see this line here. It's poking off as well, so it takes up space. So the cool thing about this one, the new one we purchased, so this thing, we have the fittings are coming off the end. So the thickness of this whole thing, check this out. Let's get this up a little. Yeah, look at this. If this thing has one thing going for it, in this one dimension, packages extremely well. This thing is thin. So we don't pay much penalty to install this in our stack up from that perspective. And if we can get around the other problems, that could be very valuable, because the dryer, I think this is true, we can put that anywhere. It has to be in the liquid line after the condenser, that part's true. But short of that, we could put it wherever it fits. So that's one of the huge benefits to this. So before it was sounding like, oh my God, maybe I should just put a stock one in there. Well, that definitely would have its advantages, but the big advantage to this one is this doesn't take up much space in our stack up. Also, because it's only like 12 inches tall, I think we're going to end up with a path to where at the very bottom of the intercooler, we'll be able to have air come into the intercooler and out of the intercooler and not have anything else in its path. We kind of did that with the, let's see, with this setup. I still have the sheet metal down here so you can kind of see. Yeah, if we look at the back side of the, it's kind of hard to get in here. Let's see, there we go. That's the bottom, 4 or 5 rows of the intercooler. Just dumps right behind it. There's nothing restricting it. That metal plate seals to the radiator. But yeah, and that bottom row just happens to be, in this case, where the pipe comes in. So this is an eBay intercooler. There's no way this thing has any internal ducting, so you can just imagine a lot of this flow goes straight across. I'm sure some of it goes up and all that, but a lot of it probably shoots right across the bottom. And that bottom row is favored to have maximum cooling. There's nothing in front of the intercooler, there's nothing behind the intercooler. So that was one of the reasons we did the ducting that way. I had to scoot the intercooler down. The other benefit of scooting the intercooler down was we have, I don't know what this number is, but we probably got like 6 or 7 or 8 inches between, yeah, you can see the very top of the radiator up there. Look how much of that radiator is unobstructed by the intercooler. So kind of a dual benefit. Your radiator has a large source of clean air, and then the very bottom portion of your intercooler, where you have the highest flow rate going through it, also has its clean source of air on both sides. So anyway, thought I'd show you that. There's a ton of work you can do in designing heat exchangers and all that kind of stuff. I'm not sure yet how far we're going to get into this. I still haven't decided if we're cutting that metal out. You can tell this could just turn into a whole project on its own, because, you know, if you keep going with it, we would cut all this out. So we should, and we would likely put something back to strengthen this part of the car back up, which that'll have to be designed and built at a minimum. If we get rid of the hood latch, that frees up some space there, because this is eating up some of our real estate. That would be cool, but now, you know, hood pins or whatever, Then there's this whole section of metal. Do we take that out while we're at it? If so, then what? I don't know. The headlights hook to that. The radiator ducting hooks to it. So you can tell, depending on how far we go with this could turn into a project. So all stuff to keep in mind. We got to figure out where we're gonna, what we're gonna do and what we're gonna wait on.